is tangent lines. And some of you might look at that and go, ew, SOHCAHTOA. It's not SOHCAHTOA. Different kind of tangent, okay? Or different use of tangent on this. But it is tangent lines. So I have a picture there of a circle and a line that is tangent to the circle. Okay, what that means is, Jacob, put that away and be with me. Okay. What it means is if it is tangent to the circle, that line is only touching the circle in exactly one place. There is one point that is the same about the circle and the line, and that is it. Okay. So we'll say in exactly one. Ooh, that's not what I want. Point. A line in the plane of a circle that intersects the circle at exactly one point. That point being the point B right here. So we call that point the point of tangency. The point where it hits the circle is your point of tangency. Here's the beautiful thing about tangent lines. If a line is tangent to a circle, then the line is actually perpendicular. That's really messy. Let's try again. Then the line is perpendicular to the radius. Okay, so you'll notice in this picture, here's a radius, right? OP is a radius. AB is the line that is tangent. That set of lines, the radius and that line, form a 90-degree angle every single time. Okay? At the point of tangency. Okay. So here's what you're going to be doing with that. Let's say you have ML, okay, segment ML and segment MN, and they tell us they are tangent to the circle. Thanks, Xavier. They want to know the value of X. They want to know how many degrees this angle X would be. I want you to turn and talk to your neighbor about what you see and what you think you might be able to do to find that missing angle measure. Go. What do we know? There's a 170-degree angle. Okay, so this one's 117. We know that. Why would they tell us these are tangent?
Because it means they're 90.
It means they're 90. It means they are perpendicular. So that means you have a 90-degree angle right here. That means you have a 90-degree angle right there. Jessica, this is the part you had correct. What value are we going to use to find X?
360.
Oh, you're not Jessica. But yes, 360. This is a quadrilateral, right? A four-sided figure. Can anyone give that a more specific name, you think? It's a kite. That's a kite because a radius is always going to be the same. Those are congruent, and then these are going to be congruent. That doesn't matter. You don't need to mark that. I was just curious how your prior knowledge was helping you out here. But because it's a quadrilateral, a four-sided figure, it is going to equal 360. So if we add this all up, 117 plus 90 plus 90 plus whatever the measure of angle X is, we should get 360. So take this away. What was that? Nico, you had that number.
60.
What? No. What was this total? Sorry. 297. So take away 297, and we get X is 63 degrees. Okay, so look for, is there a quadrilateral? Is there a triangle? What shape are we working with to be able to find the missing piece? So take a look at example 2. It says ED is tangent to circle O. What does that tell us? What is 90? Angle D. Angle D is 90 degrees. Because it's tangent, it's when it goes radius to tangent line, it will always be 90. What do you do with this one?
38 plus 90 plus x equals 180.
180 this time, right? This is a triangle instead of a quadrilateral. So 38 plus 90 plus x should now add up to 180 instead. So we're going to take away 128. And that means x is 52 degrees. That makes sense? So the thing to watch out for is when they tell you something's tangent, you should be looking for a 90-degree angle somewhere, at least one. When they tell you find a missing angle, you should be looking, do I have a triangle somewhere? Do I have a quadrilateral somewhere? Like, what do those add up to? How can I set this up as an equation? Okay? Okay, take a look at this one. It says the CN Tower in Toronto, Canada has an observation deck 447 meters above ground level. About how far is it from the observation deck to the horizon if Earth's radius is 6,400 kilometers? Okay. Oh, so they converted this already for you. Yep. This 447, they kind of rounded. This is your observation deck. So they made it 0.45 kilometers. They rounded that. So if we know all of this information, the question they're really asking you is, what is TE? What is this length? Okay, so now we're not talking degrees anymore. But they said it is the view to the horizon. That means it's tangent, right? If it just brushes the horizon, it's going to be tangent. Yes.
So would it be, what's it called? Wait, the A squared, B squared, C squared.
Yeah, Pythagorean theorem.
Okay.
Why can you use Pythagorean theorem?
You have two of them. And it's a right angle.
It's a right angle, right? This is a right triangle, and we know 2 of the 3 sides. Sorry. To just unplug that. So in this triangle right now, I know 6,400 squared plus what?
Plus X squared.
Plus your unknown side, right, is the other leg. So make sure you're adding your legs together, keeping the hypotenuse by itself. So 6,400 squared plus x squared equals what?
0.45 squared.
Not 0.45 squared.
6,400.45.
Yeah, this right here is still a radius, right? 6,400. We just have to add this little piece. They did not do a very good job of drawing this to scale at all. We just have to add that together. 6,400.45 squared. Okay, so you're going to take 6,400 squared away from both sides. So it's going to be x squared equals 6,400.45 squared. Turn the calculator on. Minus 6,400 squared. Okay, and you get this number, 5760.2025. Don't round that. That's an exact answer. So just leave the whole thing there. What do? You square root it. So x is going to be approximately, did they ask us where to round? They did not.
About,
We'll do nearest 10th. We'll see. Maybe this works out to a nicer number than I think. 5760.2025. So to the nearest 10th here, this would be about 75.9 what? Kilometers. So that's how far it would be from the observation deck to Earth. Questions on that? Okay. last thing then, and this is probably the trickiest one. This one asks the question, what is the radius of this circle? So this is tangent, meaning this is a right angle. How do you set this one up?
X squared plus 12 squared equals 8 plus 8, or x plus 8 squared.
So x squared plus 12 squared equals, and here's where it gets tricky, parentheses, x plus 8 squared. Okay, how do you square a binomial?
Square.
X plus 8, that's called a binomial, right? Two terms. You what?
Square each part.
You do not square each part, but that's what everybody wants to do.
Oh, yeah, that. Do it.
You what?
Some algebra thing
You
there.
just.
Yeah,
And
It
then
is an algebra thing.
not different.
It's a four-letter word.
8x.
It's foil. You have to foil, okay? X plus 8 squared is like saying x plus 8 times x plus 8, right? Okay, I'm going to take this real slow because inevitably some of you have forgotten how to foil, and that's okay, but you know how to foil, okay? So I will take it slow on this first one, but you know this. You've done this quite a bit. Remember what FOIL stands for. First, outside, inside, last, right? So first is the first two of each one. X times X is
X squared.
X squared, okay? Outside is you take the first and the last, the two outside numbers. What do you get?
8x.
Plus 8x. Then you go inside. What do you get?
8x.
Plus 8x.
64.
And then you go last, which is the 8 and the 8. And you're always multiplying, right? 8 times 8 is 64. So it looks like this. X squared plus 144 equals x squared plus 8x plus 8x plus 64. Then we can start to simplify. This is x squared plus 16x plus 64. Okay, first thing I would do here is I would ditch the x squareds, because if you subtract it from one side, you got to subtract it from the other, and they go away. That's 0, right? So 144 equals 16x plus 64. I would then take away the 64. So you get 80. Is that 80? That's 80. Equals 16x. And then just divide by 16. X comes out to 5. Now, want to see something? If you plug that back in, this as a 5 and this as a 5, look what you get.
Oh, you get the
5, 12, 13. So, if you're real on it with your triples and you see a problem like this, you could think, what are some triples that I know that have the number 12 in them? 5, 12, 13 is probably the only one. 9, 12, 15, but we didn't see that one a ton. So you could just try, does a 5 work here? If I put a 5 here and here, because these are going to be the same, do I get 5, 12, 13?
Yes.
Sure enough, I do. You can do it that way. It will work every time if you know your triples well. If you don't know your triples well, then do all this. Okay? Questions on that? What a great